Hello world, it's Craig. Popular Electronics and Radio Electronics were the go-to electronics magazines in the mid to late 70s, at least in the US. Pull any issue from June of 1978 through July of 1979. Pull it off your shelf and then go to the back, find Digi-Key in the list of advertisers, and then go to their ad, and you will find a significant space is dedicated to the Nibbler. It's a microcomputer at a micro price, assembled and tested for $149.95 US dollars. And the curious can just buy the user's manual for $5 if that's all you want. These are a little hard to read, so if we go and dig up our Digi-Key catalog from 1978-1979 time frame, we can get a full-page description straight from the horse's mouth. This is catalog 785 from the summer of 78. And the Nibbler's right here on page 2. And in the next catalog that came out the winter of 78, it already gets demoted to page 6. So, this lost favor pretty quickly. Says it is a standard 4.5 by 6.5 board with 72 finger edge connectors. Now, I don't know if it's correct, but in my mind, Vector pretty much set the standard for board sizes because, those are the vectors are what you use for prototyping, and the layout then carried over to the printed circuit board. 72 contacts on the edge connectors, that was impressive because STD bus only had 56 contacts on the edge connector. So this Nibbler must bring out a lot of signals to the edge connector. Memory is expandable up to 28K, a serial port of some type running 110 baud for your teletype. It speaks BASIC beautifully. I think this is a big one, and I would have led off the advertisement with this. And the board has NIBL or Nibble Basic, which is National Industrial Basic Language. It's a version of Tiny Basic from National Semiconductors. And you have to work your way to the fine print before you even learn what microprocessor is on this board. The Nibbler single-board microcomputer is built around the National Semiconductor SCMP2 microprocessor and Nibble. It includes Nibble in 4K ROM and has 2K of RAM. Now, SCMP stands for Simple, Cost-Effective Microprocessor, and I believe it was National Semiconductor's first 8-bit design. With this processor, National Semiconductor was targeting embedded systems and especially multiprocessor systems. The SCMP processor was designed for multiprocessor because it has some built-in hardware capabilities for multiprocessor applications. And National claimed that half of their processors were going into multiprocessor systems. Now, I fall into the group that prefers to pronounce it as it's spelled, SCMP. However, that was not universal. Many others preferred to pronounce it as SCAMP, with others calling it Scampy or Scamper or whatever they felt like. And I don't think that SCAMP was something the marketing department would have really encouraged. I saw one magazine article on the processor entitled something like Slow Scampering with National Semiconductor, and I think that's the sort of catchphrase that marketing would have liked to have avoided. And I've only seen SCAMP show up once in the national publications, and that's hidden in a waveform diagram. So maybe somebody with firsthand knowledge from National Semiconductor can chime in if there was any direction given regarding the SCAMP nickname. Now here's a little blurb in this book by Zax that sums up the SCMP. It says, "It's indeed a simplified microprocessor, and it is indeed inexpensive. However, the low cost of the MPU is not sufficient by itself to generate large sales. The P channel is too slow for all but the simplest, low-cost applications, and the N channel can't compete with the processing power of the 8080 or the 6800. And that's true, but I'm not sure he's factoring in the multiprocessor applications. Now, within a few years, most of these the component sellers no longer even list the SCAMP for sale with the other microprocessors. But I guess that's jumping ahead to its demise. Right now, let's focus on its Premier and the Nibbler. Now, only requiring 5 volts was a big thing. By this time, with the 8085 and the Z80, it was pretty much expected that the processor was not going to require multiple and bipolar voltages anymore. So only needing a 5-volt supply meant it was either the SCAMP 2 or the SCAMP 3, since the original one required bipolar supplies. And if you go down here and you look at this Nibbler power supply, adapter, and I/O board. And this is a nice accessory, and it's almost necessary. It sells for $40, which seems a little bit pricey. but it's purpose-built, so it would help you make a turnkey system. However, you'd also need some edge connectors and a card cage. There goes another $45. So all total, you were in for $250. And that's if you have a terminal. If we look more at the specifications, 5 volts at 1 amp. It's got plus and minus 12 volts at 200 or 100 milliamps, it says here. A 20 milliamp current loop driver for the teletype, and RS-232 for the CRT. So this board didn't have the CRT or the teletype or CRT drivers on it. You had to have the I/O board in order to get the CRT or the teletype. And I'm pretty sure that was based on the 1488, 1489 driver and receiver. Then again, they pushed the 20 milliamp current loop for a teletype. The teletype was pretty much the standard at the time because terminals were so expensive. It does have a read relay for controlling a paper tape reader. A conventional 22-pin edge connector pattern for convenient and economical I/O connection. So all that for an additional $39.95. Now, over time, I think other support cards were available for this. But remember, this is all point-to-point ad hoc wired backplane. It's not a backplane bus machine like S100. Think more Prolog boards rather than STD bus or S100 bus or any of the other buses. So as I mentioned, not only does this ad get moved further and further back in the Digi-Key catalog, but it also gets smaller and smaller. If you look at radio electronics from the last one of that year, or I'm sorry, a year later, find the Digi-Key advertisements, and you can see now the Nibbler is just this little tiny piece of ad. And that was the same thing in Popular Electronics. If I can find the Popular Electronics ad in here for Digi-Key 135. Yeah, in Popular Electronics, now you can see it's just this little ad down here at the bottom. This is November of '78. And then this is the June of 1979, and July of 1979 didn't have the Nibbler at all in the Digi-Key ads. Now, I didn't have one of these back in the day, and really if for no other reason than I was pretty much in the Intel camp. But I was looking for something in this old Popular Electronics magazine, and I came on that advertisement for the Nibbler, and it piqued my curiosity. As I've said many times, I have a soft spot for single-board computers and trainers of all types. And this little board from Digi-Key I hadn't seen before, and I wanted to track down some more information about it. Now, I have no idea how successful this board was. However, it's interesting in that this board, the documentation, and its physical and its digital footprint online seems to be nearly non-existent. I saw one posting online where somebody said that even Digi-Key themselves didn't know anything about this board. So I searched the MK14 users group since it was also a SCAMP based, and I figured that if anybody knew about this board, it would have been them, but no joy there either. Now, you can't blame 1978 Digi-Key for giving this product a worthless internet search term. Nibbler returns hundreds, if not thousands, of worthless search results. But a handful of those results, if you sort through them carefully, did provide some useful information. Now, one of those was on the EEV blog forum. And among the hundreds of posts containing Nibbler, where people were actually nibbling holes like you would expect, in a thread on the National Semiconductor Basic Nibble, there was one contributing post from a user named Granzier who, as casually as you could possibly imagine, drops the comment, "I actually have an old Nibbler PCB which runs Nibble." And I was stunned, but suddenly it seemed that there was some possibility that the boards actually existed in the wild. Well, the long and the short of it is that by way of my new good buddy, Art Granzier, back in Pennsylvania, we can gather here together to pay tribute and to memorialize this little SCM-based industrial controller, hobby computer, trainer, single-board computer, whatever you want to call it. And our end goal is not only to acknowledge its existence, but to create documentation and a reproduction work-alike version so if anybody's interested in this board, or more generally in the SCAMP processor, they can build their own reasonably authentic Nibbler board. So as far as the history of this board goes, Art picked it up about 12 years ago from his buddy Dave in upstate New York. And I don't think we know how long Dave had it or how it came into Dave's possession. Now, after having it on his to-do list for the last decade, Art accepted the opportunity to let me document and reproduce the board. So here we are with an original Digi-Key Nibbler in hand and ready to start the process. So hats off to both Dave and Art for keeping this board intact and away from the board grinders and chip poachers. So let's do a tour of the board. It's a typical low production board of the era. Hand-laid traces, double-sided with plated-through holes. The overall layout is nicely done. At least all the chips are facing the same way. Pin 1 is down towards the fingers, but I can get over that. As the ad said, everything was socketed, so these are all just standard dual wipe sockets. There is one bulk storage capacitor and about a dozen or so decoupling capacitors. I suspect there's sufficient copper in the power and ground traces. The rails are a little odd. Here's the 5-volt rail on pins 1 and 2. Starts out as 50 mil, and then it goes up the side as 100 mil, but it necks down to go around these vias down to about 40 or 50 mil. And then has this across the top by the rams. It necks down, that's about 40 or 50 mil. And then it finishes off down on the right-hand side. It's 175 mil, and that's just going down to feed this little 74 LS08 down here. So these are all 2102 1K by 1 bit RAM. So 1024 by 8 bits in each row. So it's got the 2K of RAM. And if we look at the current draw, worst case on a 2102 is 50 milliamps per chip. So 50 times 16 is 800 milliamps for the RAM. And I would have been a bit concerned with the sparse decoupling capacitors on this RAM, but the capacitors are up here on the traces that feed downward to each chip in that column. So essentially, each capacitor is shared between a pair of 2102s. But since only one row is accessed at a time, only one 2102 is turning on at a time, so I guess one capacitor will do. Now, in many places, especially on the solder side, the board looks to be over-etched. The traces thin down to nearly nothing, and several places the traces thin to the point where they were restored with solder bridges. So they did know their limitation because on the solder side, at least what I've noticed here, there's no traces that go between the pads. Now there are on the component side. They have lots of traces that go between the pads. But not having traces go between the pads on both sides of the board, let them prioritize the etching for one side and not worry so much about the other side. So here on the top, in fact, is a little bare wire that's patched on and soldered down to a trace that actually was over-etched to the point that it thinned out to nothing. So with some places that almost have bridges between the traces because they're under-etched, and other places where the traces are so thin they needed to be built up, they certainly had process control issues on this board. And it's very interesting, these were only available from Digi-Key assembled and tested, yet the assembly on this one at least looks quite amateurish. There's flux everywhere, the components are hand soldered and somewhat inconsistently. Some of the pins are only soldered on one side and they're showing bare copper on the other side. Okay, so beyond the memory, if we look at the other chips, we've got a 81LS95, that's an octal buffer. These are both 81LS95s. That's just a 74LS08, 74LS155, 74LS04. These two are 81LS97s, and this is a 74LS174, and then the two ROMs, 2316s, and then the SCMP itself, and its little clock. So I presume that 74-174 is latching the upper 4 bits address, since the SCAMP multiplexes the high address nibble. Now these two 2316 ROMs, they're not exactly pin compatible with the 2716s. The 2316 was marketed to replace a pair of 2708 EEPROMs, not in terms of pinout, but in terms of capacity. Because the 2316 essentially has a built-in 3 to 8 decoder inside. Each of these has 3 chip enables. And when that mask is ordered for the contents of the ROM, the customer specified which pattern enables that chip. And so with the internal 3 to 8 decoder, you can have up to 8 of these 2316s, and each will have a unique chip enable configuration. And you can just have their outputs simply wire or together and operated without any further decoding. So when using the 2316 for a new design, some manufacturers took full advantage of that internal decoder, and they used the 3 chip enables to do most, if not all, of the memory mapping. And in those instances, if you're going to make a reproduction board, then you've got to kludge on some other type of decoding to replace the 3 to 8 decoders that are in those 2316 ROMs. But fortunately, this has that 74LS155, and so it appears that they're using that as a 3 to 8 decoder. And if that's the case, then hopefully I don't have to add any other chips, any other glue logic to do memory decoding. So now I'm going to make a work-alike, not a replica. I'm not going to strip this board down to replicate their layout. The board I have, it's going to have solder mask, silk screen. I'm not going to do the hand layout, trace look, and so forth. And I'll run traces between the pads as needed. And also I'm going to probably bump things over a little bit so that I can put an ejector, at least up in the top left corner. And I will use a pair of 2716 EEPROMs in places of these 2316 ROMs. But I am going to stick with the same RAM. I have tubes of 2102s on hand, and even if I didn't, they're easy enough to get, and they're not all that expensive. Now the 81LS 95s and 97s, I forget exactly, there's 4 of them in that sequence. The difference are some are inverting, some are not inverting. Some of them are dual quad buffers, and others are octal buffers. So I need to look it up, and I need to figure out why these 2 are 95s and these 2 are 97s. But I'll probably stick with those original chips. They're a little uncommon, but there are direct pin replacements in the 7400 family. And if they're not actually using these as dual quad encoders, if they're just using them as octals, so they have pin 1 and 19 connected together, then that kind of opens up what we can use because we don't need to have the dual quads. We can just use the octals. So I'll have to figure that out when I actually do some reverse engineering on this board. Now I will add a header on this somewhere up here where it's accessible to attach a TTL level serial port for use with those little USB to TTL RS-232 adapters that I'm fond of. And that adapter can also provide power since we only need 5 volts for this board. So let me know if you have any other thoughts on that reproduction, because I'm going to go ahead and start plowing ahead with the schematic capture and layout of this. So there were a few other SCMP boards available in the same time frame. So what alternatives could someone have purchased in 1978 with their $150? Because that $150 in 1978 had the purchasing power of about $740 in today's dollars. So here's a lovely table from the August 77 issue of Practical Electronics. If you want to stick with the SCMP processor and you have a terminal, I would think the biggest competitor for the Nibbler would have been the National Semiconductor's own SCMP demo platform, the ISP 8K 200 kit or the intro kit here. In June of '76, it was available for $99, and it has a teletype interface on board. Also has a resident monitor. It's not basic, but it is a resident monitor. But it does only have 256 bytes of RAM. So not quite as capable of this board, but it does have some built-in interface. But remember that a terminal in those days would have set you back at least $750, if not $1,000. So most hobbyists didn't have a terminal, or even a teletype for that matter. So to address that issue with it not having a terminal, National came out with a keyboard kit for an additional $95. So for the hobbyist, boards that had a keypad and a display are much more affordable in the end. And a company in the UK called Bywood put out a few kits called the Scrumpy. And the Scrumpy 1 listed here was $62, and it had binary input and output. So it switches input and LED output. And they aren't listed in this table, but Bywood also made the Scrumpy 2 and the Scrumpy 3. And the Scrumpy 3 came out at about $210, but it also had a keypad and a TV output, as well as a cassette and teletype interface. So the Scrumpy 3 was a pretty fully loaded system at the time. And then if you want to go to the very low end, as I mentioned earlier, there was the Science of Cambridge MK14 that was selling for about $52, which was a third of the cost of the Nibbler. And it included a little keyboard and a display, so as limited as that keyboard and display were, it was at least usable without a terminal. So it was a pretty good deal, but I'm not sure how readily available they were here in the States. The same with the Bywood system. I don't think they were available here. And likewise, I'm not sure if the Nibbler was available over in the UK because, in 78, Digi-Key hadn't been around but a couple of years. All in all, at $250 or at $150, the Nibbler was, a fairly good deal, providing that you were interested in the SCAMP processor and you had a terminal or a teletype and you were willing to either make your own serial interface or spend the extra $49 to buy the serial interface on the power supply board. So it would really be interesting to find out how many of these boards were actually sold or if it turned out to be a white elephant for Digi-Key. Now, one thing that had to be an issue with sales for the Nibbler is that over the entire year of these magazines, the price remained at $149 for the entire year. And during that same period of time, the National Instrument, their trainer, the ISP-8K kit, that was $99 in June of 76, a year later they were selling them for almost half that amount. So as the year went on, it got harder and harder to justify the Nibbler over all the other platforms that were getting ridiculously cheap for the time. So that's it for the introduction of this board. I'm going to proceed with capturing the schematic and laying out a work-alike board. Again, thanks to Art for giving me the opportunity to capture this little piece of microcomputer history. So that's it for this video. I will talk with you later. Thanks for watching. Bye-bye.